Okay, so for number 4 on, this is homework 3, we notice our A and our B value are looking like they're about the same, but they're not, because one of them is negative, and we know from our reference sheet that, like I just said, this is just for the video if you want to go back and watch the video. If either A or B are negative, then you have a hyperbola, and that is what we have here. A and B are not the same sign. One of them is negative. So we're going to put, basically B is negative. Therefore, we have a hyperbola. And that's the first part of our answer. Just identify what we have. So if we have a hyperbola, we're trying to get an equation that looks like a hyperbola, and that's going to look like either this or like this. Okay? Like this or like this, depending on how it opens. Now you can see here which one is positive. So we know this hyperbola is actually going to open in the left-right direction because x is positive. Since x is positive, it opens right and left in the x direction. So what I'm going to do now is I'm going to complete the square for this. And again, it's just like the circle. I need to get these rearranged. So I'm going to go x squared. And what's cool about that is I don't have any other x terms. So all I need to do is leave that as it is, because that is a perfect square, right as it is. That's a perfect square. I don't need to add anything to it, subtract anything from it. That's a perfect square. Perfect, good. So I've completed the square for x already. Now for the y. Well, the y is a little bit different, but that's okay. So I'm going to go negative y, so just going to organize this the way it ought to be. Minus y, minus 4y, sorry. And then I'm going to leave a space where I can add something. Okay, and then I'm going to move this negative 13 over to the other side to make that a positive 13. So I move that over, and that's going to be the case for everything except for a parabola. You're going to take that constant and move it over to the other side. Parabolas are a little different. I'll do one of those in just a little bit. Number 2 is a parabola, as we'll see. So we've completed the square for x. That's great. So that one's done. We need to complete the square for y. Let's see, we have a negative out here in front of the y. So what I'm going to do is I'm going to factor out the negative, okay, first. So I'm going to take that negative out, and I'm going to make that into a y squared plus 4y, and then plus something, that's going to go there, equals 13. There we go, so you can see it. You see what I just did? I factored out a negative from the y and from the 4y. You can do that so long as you identify what you're factoring out from. Now I've got a perfect square almost right here, but I need to add something to it. So I take the b, I cut it in half, and then square it. What do I add? 4 divided by 2? Yeah, 4. Okay. Yes, because that's what I always do when I complete the square. Okay. The other thing is I can't have a coefficient in front of this variable. Okay, so I got rid of it. The coefficient is actually a -1. So this is a little bit tricky, you guys, because I actually did not add 4 to this side. I subtracted 4 because I took out a -1. So I need to whatever I factor out, I need to redistribute that to whatever I added. So in the parentheses, it looks like plus 4, but really because I've got those parentheses, I took out a -1 from everything. I really subtracted 4. So I took away 4 from the left side there. So if I did that, I'm going to have to take away 4 from the right side. And now that might make a little more sense because you've got 9 over there now. Okay, so we now factor this. This is already a perfect square, x squared, great. But then what's in parentheses here, we factor. So that's going to be taking the square root of y squared, take the square root of y squared, take the square root of 4. So you're going to have this minus coming down here, and then I'm going to go in parentheses. Square root of y squared is y, and because I have a plus sign here, I'm going to put a plus sign in there, plus, and then I take the square root of that 4, and then that's going to be a 2 in there. And then I square it, because that's what that factors into. Except there's a negative in front of there. That's all I have. Okay, it's just that negative, which is fine. I've got a negative 1. Okay, I can put that negative 1 in front there. That's fine. And then equals 9. So here's the only thing with a hyperbola, and that is that for our hyperbola, if you notice, the hyperbola, both hyperbola and ellipse, you've got your graphing equation equal to 1. Okay, it needs to be equal to 1. So the only problem we have here is that we've got a 9 here. So how do we get 9 into a 1? How do we do that? We don't subtract 8. I mean, we could, but then we'd have to subtract 8 from this other side, and it looks ugly. So what we're going to do is, when we're almost done, except not, we're going to divide this by itself. Divide that by itself. And then we're going to, because we divided the whole right side by 9, we're going to divide every term on the left side by 9 as well, because that's the same thing. Actually, why don't you just divide the whole thing by 9 so you can see what I just did. Divide that so we can get 1 here. Okay. So now what I'm going to do is I'm going to take this, I'm going to split this into 2 fractions, right? Because this is 1 fraction, and then this is another fraction here. So what I have is x squared over 9 and then I've got minus y plus 2 squared over 9 equals 1. Now, this is basically our form that we need for our answer. That's what we need. However, how do you identify what the center of this hyperbola is? How do you identify what the center is? We know the opposite of k right here is negative 2. That's fine. But what's the opposite of h? So here's how you have to think. If ever you see this, that basically means this. X minus 0, right? So you can now see what the center is. The coordinate for x was 0. And this is really how our hyperbolas looked last week, is when we had 0, 0 as our center. So that would just mean the x coordinate is 0. The y coordinate is negative 2. We have it equal to 1. Therefore, we know our asymptote is going to be positive and negative a over b. A is always under the x. So, or sorry, excuse me, b over a. So it's going to be positive and negative 1 for our asymptote. But we're not asked for that. So really our center is going to be (0, negative 2). Okay, 0, negative 2 for our center. So we've got every little part of our question answered. We've got our basic form. If you understand that that means 0, that's great. Okay. We've got the fact that we identified it as a hyperbola. So 1, 2, and 3, and we're done.